and his car's heater felt too hot. There had been nothing in the forecast that morning about freezing sleet, but now the streets were coated with translucent slush. It wasn't that slick, but traffic had slowed to a crawl anyways. What was worse, Dan knew his girlfriend Cheryl must already be at their favorite restaurant waiting for him. Dan could see the restaurant's tall sign on the other side of the highway bridge, glowing in the gathering darkness. Dan was going to propose to Cheryl, and he didn't want to be late. Frustrated, Dan pulled onto the shoulder. It wasn't far. If he could just get across the bridge's narrow breakdown lane, he would be there. But Dan didn't realize that the temperature had dropped as the sun went down, and there was now a growing layer of glass-smooth ice under the slush. As Dan pulled into the narrow breakdown lane, his car's back end slipped a little. Unfortunately, it wasn't enough to make Dan change his mind. He drove too fast toward the bridge, ignoring the honking from the other cars around him. A few yards from the bridge, Dan sped up a little. The extra torque on the back tires caused the car's rear end to slip out again, only this time it didn't stop. Dan pumped the brakes, but it was too late. The car's back end broke through the guardrail and slipped off the shoulder, pulling the rest of the car over the side. Dan fell 20 feet onto the freeway, where a sliding semi-truck slammed into him. Dan was killed instantly. He never got to propose. Certain weather conditions can greatly increase the chances of accidents. Statistically, driving accidents occur at highly elevated rates during hazardous weather conditions. Hazardous weather conditions can include snow, sleet and ice, rain, and fog. It's important to know what to expect from driving in hazardous weather conditions and how to plan ahead and protect yourself. This course is designed to provide you with the knowledge and skills you need to avoid motor vehicle accidents during hazardous weather conditions. When this course is over, you should be able to identify the major weather-related hazardous driving conditions, the safe driving practices to use in those conditions, and recognize the preparations recommended for hazardous driving conditions.
Some of the most dangerous driving conditions are caused by cold temperatures. In winter, snow, sleet, and ice can lower visibility, increase stopping distance, and make it more difficult to control your vehicle. Snow makes vehicle traction difficult, and hard-packed snow makes traction even more difficult. Ice is probably the most dangerous winter road hazard. Packed snow can sometimes melt just enough during the day that when it refreezes at night, it becomes slick, solid ice. Freezing sleet is also often very hazardous because as it accumulates on the road, it freezes into a single sheet of ice. Freezing sleet can sometimes cause a hazard when it accumulates on tree branches above roadways. As the sleet builds up on branches, the growing weight can cause the branches to break and fall on or in the path of passing vehicles, causing accidents.
Many drivers don't think of rain as being a driving hazard in the same league as ice or snow, but rain brings two serious hazards. The first is lack of visibility. Depending on how heavily it's raining, your ability to see other cars, pedestrians, and other obstacles can be seriously affected. The second hazard is a lack of traction. As with snow and ice, wet roads can be very slippery. Wet roads are most slippery right after it begins to rain. This is because oil that comes from thousands of cars passing over the road rises when it gets wet. This creates a slippery film that sits on the road until there's enough rain to wash it away. Rain can also splash up onto your vehicle's brake drums, reducing the braking system's effectiveness. Possibly the most dangerous hazard of wet roads is hydroplaning. Hydroplaning is especially dangerous because it usually requires a relatively high rate of speed for it to occur, making an injury more likely in a collision. Hydroplaning is caused when a vehicle's tires pass over water in such a way that a thin film of water is created between the tire and the road. When this happens, the vehicle is, in effect, floating. The tires aren't touching the road, meaning there is no traction. Once the vehicle is hydroplaning, it is very difficult to stop and will usually continue until the vehicle runs out of momentum, hits something, or stops hydroplaning. Another weather condition that can cause a driving hazard is fog. Smoke, which isn't caused by weather events, causes a similar hazard. Driving into fog or smoke will most likely cause a severe visibility problem. In fact, Depending on how thick the fog or smoke, you might as well be driving while wearing a blindfold. Visibility can be as little as a few feet in front of the car in thick fog and smoke. This makes it very difficult to see what's happening around you, and it also makes it difficult for other drivers to see you. Even simply pulling over can be very difficult in fog or smoke. What's worse, fog and smoke can last for yards or miles depending on conditions. The easiest and most important way to avoid hazardous weather conditions is to pay attention to weather reports. That way you'll know what to expect and can plan ahead. Once you know what you're up against, you should follow some basic safe driving strategies. When the roads are snowy or icy, the first thing you should do is clear your windows and mirrors. Turn on your defroster to help eliminate the condensation on the windows, melt any ice or snow on the windshield, and if your vehicle has one, turn on the electric defroster for the back window. Make sure all windows and mirrors are cleared of ice and snow before you get on the road. It's also a good idea to drive with your headlights on when it's overcast. This will help other drivers see you from a distance. Once you're out on the road, maintain a slow, steady speed. Even if the road just seems to be wet, there can still be patches of thin ice the color of the road, also known as black ice. You should be especially cautious when driving over bridges, overpasses, and shaded areas in the road. These surfaces tend to freeze quicker than other parts of the road and stay frozen longer. You should also be careful of other drivers and allow extra following distance when driving on ice or snow. In northern parts of the country that experience colder temperatures and consistent snow and ice on the roads, you might want to have snow tires or chains installed on your car. However, snow tires don't do much good in deep or hard packed snow, and snow tires and chains can give a false sense of security. If you do start to skid, apply your brakes in a light pumping action and try to steer the same direction that the back wheels are sliding. While driving in rainy, wet conditions, you should make sure your windshield wipers are in good working order before getting on the road. Once you're driving, adjust your speed based on how heavy the rainfall is. The harder it's raining, the slower you should drive. You should also allow at least twice the following distance you would allow in normal weather conditions between you and the traffic ahead. Avoid driving into standing or moving water. If you do drive into water deep enough that it might splash into your brake system, slow down and apply pressure to the brakes as you pass through the water. This will help keep the water from entering the brake lining. After passing through water, test the brakes. If they aren't functioning as well as they should, apply light pressure to the brakes as you drive to try and squeeze the water out of the system. To avoid hydroplaning, slow down when driving on wet roads and make sure your tires are inflated to the correct air pressure. If you do start hydroplaning, take your foot off the accelerator and hold the steering wheel as straight as possible. Don't hit the brakes, but slowly and lightly apply them. If at all possible, you should avoid driving into any fog or smoke, but you should absolutely never drive into heavy fog or smoke. When driving in lighter fog or smoke, use low beam headlights, drive slowly in the right-hand lane, and be ready for a fast stop. If visibility gets progressively worse and becomes less than a few feet, you should leave the road and park with your hazard lights turned on. Leave your vehicle and go someplace safe until the fog lifts. Vehicle maintenance is an easy way to avoid many driving condition hazards. Regular tune-ups can mean easier starts, faster pickup and passing speed, and better gas mileage. While many people find it easier to take their vehicle to a garage for a tune-up, it's not difficult to do it yourself. In cold winter temperatures, it's important to make sure your battery is charged and in good condition. It's also important for your tires to be properly inflated. For proper traction, the tire should have enough tread to pass the penny test. To perform the penny test, simply place an upside-down penny in the tire's tread. If the top of Lincoln's head isn't covered by the tread, the tire should be replaced. Vehicle's antifreeze should also be checked before driving in any weather. Make sure to use the correct type for your vehicle. Under the hood, you should check the spark plugs, ignition, wiring, hoses, and fan belts. If there are any frayed wires, cracked belts, or hoses, they should be replaced. If your vehicle is an older type without fuel injection, check the distributor above the carburetor for wear and proper adjustment. While you're at it, check the air, fuel, and emission filters. Also, check the positive crankcase ventilation valve, which is usually referred to as a PCV valve. These valves can cause general problems with the engine if they're not working properly. Finally, make sure you have plenty of gas in the tank. You won't get very far without it. Because almost anything can happen on the road, it's best to be prepared. Some general equipment you should always have before driving includes a properly inflated spare tire, a wheel wrench, and an approved jack. Jumper cables and a tow rope or chain can also come in handy when you least expect it. And you should have a general repair toolkit in the trunk. In winter, you should carry a shovel and a bag of salt or cat litter to provide extra traction if you get stuck in a slick spot. It's also good to have a set of tire chains with you. Of course, you should always have a reliable ice scraper and a snow brush. You should be able to identify the major weather-related hazardous driving conditions and their safe driving practices, and recognize the preparations recommended for those conditions. Be careful and stay safe out there.
Okay, that's the end of the video. Does anybody have any questions or comments on the hazardous driving conditions? So the one thing that I would say that we didn't really see a whole lot of is the driving with the trailer. You guys know that a lot of projects require us to take the trailer, the high current test set, and that kind of stuff. It's extremely important, this time of year that we make sure that we're making sure that all the equipment is properly battened down or secured properly. We do want to make sure that we take extra time. If we have to, let's take the trailers out, try and stage them the day before if possible. Give ourselves plenty of time to drive. And just like Tony had mentioned last time when we talked about, inclement weather and conditions, make sure you're prepared. Have blankets, any kind of road hazard warning like flares or the LED lighting or something. Maybe some extra water, some electrolytes, Gatorade or something in the vehicle. Just be prepared. It's much easier for us to arrive to a site maybe late than not get there at all because we had to drive super fast or something getting to a site. Make sure that we're looking at weather conditions ahead of time, especially you guys in the north. You guys know you're going over the passes and stuff. Weather there can change in a heartbeat. So just make sure you're prepared. We have proper clothing and stuff for that.
Hey, Matt, this is Jason. Can you hear me?
Yeah.
Okay. I wanted to say that in the video, there was something out of Matt's era about using your brakes during rain and snow and ice. And for most of the vehicles of today, you do not pump your brakes. You have analog braking systems, so you can just go ahead and use the brakes as normal. The computer will do the rest. Pumping your brakes with analog brakes actually defeats the purpose.
Yeah, that's a good point, Jason. Thank you for bringing up my jalopy. But yeah, that's a great point. Thank you.
I was just talking about your age and what you probably learned to drive on.
Hey, this is Tim. If I can add a couple of things there. First off, when you get into worse driving conditions, we all need to definitely switch our state of mind to defensive driving and defensive driving only. I know a lot of times traveling as much as we do that we get stuck in this aggressive, oh God, I got to get there. We're passing people left and right. But when conditions get worse, it doesn't matter. Switch it to defensive driving, slow down. Back off, don't need to be passing people and everything else. The other thing is also 9 times out of 10, when you do start sliding, it is because of overspeed. And realize that traction is based off of pounds per square inch of rubber on the pavement. So whenever you push on that gas pedal, you reduce that PSI on that pavement because now you add torque to it, and that reduces your PSI. So 9 times out of 10, you can just take your foot off the gas, and that will control your slide in itself. Worst case scenario is panicking and stomping on the gas like you normally stomp on the brake. But either way, 9 times out of 10, if you just take your foot off the gas, the vehicle will correct itself without a panic at all. You don't even need to pump on the brakes or stomp on the brakes or hit the brakes. It's just stay calm and keep control of it, because 9 times out of 10, that'll cure itself.
Yeah, all good points. Thank you guys. One more thing, Darren brought this up last time, talking about chains. To be honest, I live in Southern California. I wouldn't have the foggiest clue how to put chains on my car or truck. That's something, especially for you guys up north. If you guys don't know how to do that, talk to your guys, because there's a lot of those passes I know that you're not allowed to drive unless you have chains. So, make sure that we have those available and you know how to use them. So I appreciate Darren bringing that up last time.
Hey, Matt, this is Tim again.
Hey.
Since you brought up chains, I do want to bring that up. I was traveling from Oregon down to California, and I had to have chains for my dually. They actually asked me to stop and show them the chains, and of course I did. Went down through California, and I went from California into Nevada up over them passes going into Reno. And they actually stopped me and told me that I had to go buy chains for my trailer at that point. So think about when you're pulling a trailer at different passes, they might require chains for trailers. They might require chains for the vehicle. They said with my dually that I was able to have just chains for the back. I didn't have to have chains for the front, but they wanted to see chains for the front. So, you might actually have to carry quite a few sets of chains at some points.
Yeah, as far as the chains in the north, if you are from the north, live in the north, and you don't know how to put chains on your vehicle, just turn your keys in to Ramona.
Yeah, there's openings down in Southern California.
Happy to have
You
all
can live with Matt.
Okay, any other questions, comments? Okay, Joey, you ready?
I'm here. Can you hear me?
We can.
Okay, so I did this PowerPoint, this presentation probably a year ago now, and just recently, because of some of the CT tests that I've seen, I thought this was a great opportunity to go over this again. Can you go to the next slide, Matt? So the current transformer is a type of instrument transformer that is designed to produce an alternating current in its secondary winding, which is proportional to the current being measured in its primary. Next slide. It's the function of the current transformer is to convert primary power signals to manageable values for meters, revenue metering, protective relay systems, power generation, plant monitoring, fault recorders, SCADA, overall electric grid monitoring, building management systems, load control, insulation from high voltages and currents. Next slide. Isolation from other systems, safety, standardization, accuracy, typical low power rating, thermal considerations, burden considerations, and you can see the list so on. Next slide. So the way that I wrote this was off of my experience with the EasyCT 10. If you have the 2000, it's obviously going to be a little bit different, but I kind of set this up for how you set up the test set and then how you run the test, how you set up your test plan. Obviously, everybody knows this is what it looks like. Next slide. So we're going to go over EasyCT setup, communication with your computer, the application setup, the window, the test plan creation, and then testing the CTs themselves. Next slide. So super dumbed down, remove the lid, connect your ground cable to the test set, connect your primary set of leads and your secondary set of leads. Obviously, here's a picture that shows you every connection and what everything does on the top of the test set. Next slide. And then here's a list that explains all the item numbers on the previous slide. Next slide. Then you want to connect your RS-232 cable to the test set, connect it to your dongle, connect it to your computer, turn on the test set, then open the software, and then I just remember it's 2, 4, 1 in that order to communicate with the test set. Next slide. And this is your application setup window. I've seen, and I've done it myself, where I've had the use USB port selected, and if I remember right, that needs to be deselected or unselected. Next slide. Your default print orientation should be set to landscape. Use USB port, like I said, should not be selected. The frequency is 60 hertz. Your date format's there. You need to have replaced the Vanguard logo with the WES logo, which is pretty easy in the software. All the other selections should be default settings that do not need to be altered. Next slide. So this is the top bar that tells you we're actually going to select test plan, and you can see that this is version 5.4. I've found over the years that it has the least amount of glitches, and hopefully that's what I'm using today. Next slide. So I want to make sure I focus on this screen a little bit. One of the issues that we have is that we have guys that they'll use very minimal information in the station circuit blocks, and then we have the other side of the coin where we have guys that they want to write a novel in there. I see that where it says MSB 1A TAC FB2, I see that there's a lot more space in there to type a lot more stuff. The issue is once you convert it to a document and you save it and you PDF it, it's going to cut off 50% of the characters that you put in there. Same thing goes for circuit. So you really have to pay attention to this, or maybe the name of the breaker will be cut off, or maybe what CT, what phase it is, will be cut off. And this week alone, I've seen both of those things happen. So I wanted to bring that up. The other thing I wanted to bring up is the top boxes where it says ratio test and excitation test. If you select those, it'll check mark every single test. And the easiest way to do it is to check mark the boxes in the line next to X1 to X5. And we do a lot more single ratio CTs than we do multi-ratio. But even with the multi-ratio, you do not need to run every one of those tests. And then obviously you want to choose the right excitation voltage. Next slide.
Hey, Joey.
So click on the test. Yep.
Can you go back to the last screen for a second?
Okay.
So just to clarify something, usually, when we're doing a multi-ratio CT, we only do excitation on the full winding. Just keep in mind that you're testing per the customer specs. So if there's specs that say, hey, we got to test excitation on every single tap, we got to do ratio on every single tap, you got to make sure that you do all those tests. So just pay attention to the specs you're following.
Yeah, and one of the things I would say is that the difference usually is the difference between ATS testing and MTS testing. Typically, MTS testing, you'll do the in-service tap. For ATS testing, you'll do all the taps. But yeah, Joel, I think you're absolutely right. It depends on the specification. We need to make sure that we're reading that and getting that accurate.
Okay, so in the middle of the top of the screen, click on Test Plan, select Create Test Plan from the drop-down menu, fill in the pertinent information. Again, use as few characters as possible so the information will fit and will not be cut off by the program's limitations. The company is WES, station, circuit, manufacturer, model number, serial number. The serial number and the operator need to be filled out once the test is complete before you save it and print it. Comments, again, pay attention to the number of characters you use here. The knee point marker, I want to say that the majority of the time we're using IEEE 30 degree, but that is a drop-down menu. Next slide.
Hey, Joey, I have a question real quick. For company, is that WES or is that our client? The client name.
Well, Matt, you're the VP. You're the VP, so you'd have to tell me. I've put WES for 5+ years, and
I would think that we would want to put our client name in there, just like all of our data sheets. The test plan itself has our logo on it, right? So we know who performed the test. But I would think that the company would be our client.
Okay. And then maybe that's what I put. I haven't tested CTs for a little while, but so do not select ratio test or excitation unless you'll be performing every one of them. This is where you add your nameplate ratio. Excitation voltage is a drop down that you select. Test notes, we've gone over that. Select save, create a file. The way that I do it is I'll create 600 TAC 5, and I know that that's my 600 to 5 test plan. 1,000 TAC 5, that's my 1,000 to 5 test plan. And I save those test plans because I use them over and over and over again. You need to save it as that type of plan. Select save. Next slide. And here is just an example of a connection, one type of connection when you're testing from the test set itself. Next slide. Then you'll see run test, which is 2 over from test plan at the top. You're going to select run test. Connect your H1, H2, X1, X2 leads appropriately. Select run test from the top of the screen. Select save test plan you intend to run. Select run test, start test. You're going to ramp your voltage current up, not exceeding 2 amps. It'll beep at the test set beeps at you when you hit the 2 amps. What you want to see is the CT saturate, and you will see that because that value will start increasing quicker when the CT saturates. You get to that point, you want to slowly ramp down to 0. You're going to hold it there for a moment, and then you're going to slowly start to ramp back up until you receive the value that you're expecting. And you should know that by just experience testing these CTs. You may have to fine tune that dial to achieve that expected ratio within that accepted tolerance. This is hugely important. You need to know what your tolerance is based off of what CTs you're testing. It's not just a value that you get that's close and you go, that's acceptable. I just looked at some CTs that out of 20, I think a quarter of them failed, and there was nothing written about it as failures. It was almost like the person thought that they passed. You have to look at that nameplate on that CT and do a little research and find out what that acceptable tolerance is. Next slide. Obviously, these are the screens that you're going to see. Run test plan. Yes. Next slide. This is what your screen will look like when you're going to start the test. Next slide. Key items to check after performing. Polarity. If you do not see in phase or out of phase, if you see NA, something is going on. Obviously, if you see out of phase, there's a problem there, but you need to look at that. You need to see, is the ratio acceptable. On the newer software, there is a knee point marker, which is a square black box. If you do not have that, you did not reach that knee point. And so the length of the curve, I don't know that matters as much as it used to now that you have that square black box. That signifies that you've hit that knee point. The data, are your data fields correct? Are they all filled in? Just like one of our data sheets, same thing with this software, a blank line is not an answer. You need to have something there, whether it be NA or something, the nameplate. Next slide. And this is what it'll look like when you're all done. I can see that Matt Thomas did an amazing job. He filled in every single line. It all fits. Something that's really key here is at the top left under the WES logo, the file name, everything fits there. Quite a few of us were just on a job a year ago that the file names that we had to use were so long that every CT they would get cut off. So we had to make some changes and shorten the file name and then turn around and add some of that additional those additional characters to the station line. And I think we did a pretty good job, but for the most part, you're not going to have the amount of characters that we had on that data center job. Next slide. So then you save as a source file, you print a PDF, double check your data once you print into PDF for errors caused by the software's character limitations. Just like we would do on any data sheet, review it, make sure everything's good, because you're not going to have an opportunity to go back and retest that CT more than likely. And on top of that, one of the things I hate doing is I hate having to go back and reopen a CT source file to make corrections, because it is so much easier and so much faster when you do it while you're doing the tests. So if you're able to do all that, then congratulations, you have tested a CT. And I hope for some of the new guys that we have, this makes sense. I can tell you that there's been multiple new guys that have used this PowerPoint with no direction and have tested CTs correctly. And so I know that it works, and you can reach out to guys, and you'll probably find out who those guys are. And I think that's it for me, Matt.
Joey, this is Joel again. I just have a couple things. When we're printing the PDF, what pages are we printing? Because I know the report has up to 5 pages.
So the standard that I know of that has been there for a while is a single ratio is 3 pages. You delete the third page. You keep the first 2. A ratio is a multi-ratio is 7 pages, 8 pages, something like that. You keep the first page, and then each individual page that has the color of the phase. So off the top of my head, I don't know the answer for the multi-ratio, to be exact. But
okay, well,
does somebody else have that answer?
That's my question. Is that I've looked at a lot of reports. The first page, like you have here, has the ratio, it has everything, it has the graph, and it has the CT data points. There's also a summary page which has pretty much all the same information except for these data points. So I guess my question is, why do we print both of them when a summary page would have the excitation curves and the ratios and all the pertinent information? Or do you understand what I'm talking about?
No, I understand exactly what you're talking about, and what I would have to say is, Tony, are you still on the line? Can you answer that question?
What I don't think Tony is, but what I would say is, and I've had the same question. I think it's a great question. I don't think after that first page, I don't think that I think all the information behind that is all repetitive. And so, in my opinion, especially on a single tap CT, that this is the only page, the one that you see here on the screen, is the one that we need. It's got all the information. It gives you the ratio, whether it's in phase, out of phase, and all your excitation points. Everything after that is just repetitive. So in my opinion, we should just go with the one page.
Hey, Matt, this is Tim. So what we did in the past, you're correct on the single ratio. It's just a front page. I know for a while there was wanting to save 2, but that's a little silly to me also. But on your multi-ratio, what we saved was this front page that had all the graph points on it. And then I thought it was the last page that had all 5 on the same page, or all, however many multis there was, but all of them all on the same page that didn't have the points on there, but it still had the graph and showed the general entire CT all at once.
Yeah, and I think that's a good idea. I would agree with that. If we could do the first and if that's the last page, then I think that's what we should do.
Okay, and then one more thing on that. Other tests that we do on a CT, such as insulation resistance, single point grounds, are not documented in here. So I guess if we're doing those tests, what do we turn in for documentation on those? I know in the software there is a notes that you can add notes, and that prints out on the summary page. For instance, you can put in there, insulation resistance test at 1,000 volts, and you can put the value in there. But as far as right now, we really don't have anything that documents that, other than this form that you're pulling up right now.
So I don't know who we're waiting for an answer from, but what I would say is that I thought that we were, if on a single CT circuit, we would still fill out this sheet on the circuit itself, but as far as ratios and that, we wouldn't put that information in there. But this does give us a chance to take a look at single point grounds. That's on our sheet here. We have all the information about the CT itself, but I don't know the standard that we've been using, to be quite honest.
Matt, I had to take a call. This is Tony. I'm jumping in here late. Sorry, I missed the last part of the conversation. Click on 3 CTs, no PRS, please.
Okay.
Yeah.
That's what we're supposed to be doing. So that right there, in addition to your Easy CT, gives you everything that you need. That's why we developed that 3 CTs, no PRS. Now the 3 CTs worksheet is because we do have a manual test set, and there are scenarios where someone's going in with a power supply and doing minimal testing, or there are those situations. So we wanted to have a full CT form when you don't have an automated test set. But that's what the 3 CTs no PRS is. It gives you your nameplate data, your visual mechanical, your insulation resistance, and then your circuit burden, that are all requirements on most ATS projects. Silence to me means nobody's doing it.
No, no, we are doing it. It's in our data sheets. I just didn't realize that it was a separate tab.
Yeah.
But I know
well,
that.
And is Tim still online? Is Tim Klosterman still on the line? Because I'm going to ask you, Tim. I thought that, and Tony, this is for you as well. I thought that the way that we were doing this was we were actually adding the burden and the insulation resistance and the single point ground to either the meter or the switchboard form, and not this individual form.
The
I
problem
thought that's the way we
is that
captured data before.
the
So
problem
what
with
we've
that
done
is
is
the CTs may not be for a meter. It may be for relaying or something else.
Yeah, so you have multiple options, and that's exactly right, Matt. You have multiple options depending on what equipment you're testing. And so yeah, if you're testing a meter, that is one place that you can put that information, is in that metering device form. But what it's not going to give you in the metering device form is it's not going to give you a visual mechanical. It's not going to give you all the nameplate data. Now, so you got to make sure that whatever other form you're using has, all the accompanying information.
Yeah, Joey, this is Tim. If you remember right, that was for site specific. That was just for that one job that we did that at. I don't think that was supposed to be a norm moving forward. I think it was just for that one job.
No, to be clear, hold on, Joey. To be clear, this is the standard going forward. It's not a job specific. So if you have a meter and you scroll down a little bit more, Matt, scroll down a little bit more. So here you've got your circuit burden, circuit verification, right? You're able to document this for a meter, but it doesn't give you that data on the left-hand side of the screen there. It only gives you that circuit burden data. Well, what about insulation resistance? What about visual mechanical? What about nameplate? So if you go back to the Easy CT, there's very minimal information that you see on the left there in that document. You've got some minor basic nameplate data, but you don't have full nameplate data. You don't have insulation resistance. And what else are we missing?
Burden. Oh, just as far as nameplate?
Well, yeah, burden could be on the again, we're giving options. Burden could be on your metering data sheet or on your CT data sheet, depending on what you're testing and what you're using.
It doesn't have voltage class, ratings, type, catalog, that kind of stuff.
Right. Yeah, it's not 100% complete. Oh, the other one that's missing is single point ground. Part of your visual mechanical right there, right under where Matt just circled, is your single point ground. Where are we documenting that at? So the answer is that with every CT you test, you really need to do circuit, a CT form, so that you have everything. Where's that at? Oh, is that included in the? Oh, okay. So we did have that in the visual mechanical. Okay, all right.
So you really needed to do that CT form with everything. And then Matt brought up a good point, or Tim, whoever said relays. Yeah, none of this as far as relays. There's no place to document that when you're doing a relay test.
So I think the direction moving forward, so just to get back to the core answer or question, so this document here, the CTs, will always be filled out, no matter what we're doing. Some of the information is kind of repetitive because we got single point grounds and stuff like that. That's fine, but I think moving forward, the answer is that the CT form or data sheet will always be filled out, and that will accompany the easy generated data sheet that we have.
Okay, so I I understood what you said, Matt, and I would just say that we need to make sure that everybody knows this, because me personally, I have never even looked at that other sheet, so I've never seen it in any report. So as far as I know, nobody has ever used it. That form right there, the 3 CTs, no PRS.
Well, I know for sure that it has been used. I remember specifically someone like Jim Botsford. Maybe Jim is just ahead of his time. But moving forward, this form does need to get filled out so that we make sure that we get, like Tony said, all the information on the nameplate, the visual mechanical. And again, that should go pretty quick, right? This is one data sheet for a group of 3 CTs. So.
Okay.
And this is a great opportunity for us to discuss that, right? So yeah, site leads, we'll start looking at that a little bit closer if we haven't been doing it. It's just something that we'll continue to push and improve on in the field.
Thanks for the clarification. I think that clears a lot of stuff up for a lot of people. The last thing that I want to say is, when you're checking polarity, you got to make sure that you're doing it per the drawings. I recently I tested some CTs on a transformer, and typically, if you've been around for a while, you know that the polarity on a CT on a transformer is always towards the bushing side. And as I was testing, I noticed one phase was opposite. So digging into it, figured out that one of the CTs is either installed backwards or the secondary wiring was backwards. Just pay attention to that stuff. When you're checking polarity, you're checking it per the drawing, and if you don't have a drawing, you gotta ask and to what it's supposed to be.
To add to that, Joel, I would also say that not only are we checking that polarity is correct, but we also have the correct ratio. We've seen several times where the CT ratio didn't match our drawings. And so we need to make sure that we're verifying what does our drawings say the CT ratio should be, and does that match the actual? And if it doesn't, then we need to bring that to the attention of our client and get clarification on that. Either the drawing is wrong, or they need to put in an RFI if it's an ATS project and just get clarification.
There really is no time where you verify based on history.
No.
Or experience. That really doesn't apply. You're going to make a mistake. It comes down to, like Joel said, it comes down to the drawings. And who knows? I mean, you may very well find that the drawings are incorrect. There's been many times where we found the drawings were documented incorrectly, and then we had to go back and write up an RFI or something, and sure enough, the design engineer, they go, oh no, that's what we meant. We meant 3,000 to 5. That's what it should be. And here we are. This is our livelihood. Like, it says 600 to 5. There's no way. So yeah.
And in this particular case, this was a CT that was being used for transformer differential relaying. And if you know anything about that, if that wasn't noticed and they went to energize, it would have tripped offline due to differential current, even though there wasn't any fault.
Yeah, go figure. Whose fault is that? No pun intended, but whose fault is that? It's not the design engineers. It's that we didn't catch it, right? Everybody's going to look at us and go, well, you guys tested it. Why didn't you catch it?
And so just real quick, I think most of you guys know this, but when you look at the drawings, you should see, when you look at a CT, and pardon my elementary drawing there, but you should see a set of dots.
What is that? Is that a
Those
clothesline?
polarity marks. What's that snide remark you're making?
I said, is that a clothesline? What is that?
Me and my jalopy and you and your clothesline. So what you'll see, this is the polarity marks. So this is your H1 on your primary side. On your dot, it's going to be your X1. So keep that in mind when you're looking at the drawings. That's how it's all shown on the drawings, is how we should test the CT. That's going to tell us whether we're in phase or out of phase.
Now draw the test leads. Well, you don't have to draw a test set, but you know, where would your H1, H2, X1, X2, you know, for a in phase polarity check? Yeah, so you're going in H1, return H2, in X1, return X2. Because you draw this, and I would say that probably, well, I don't know how many people, but quite a few people look at those polarity marks and don't truly understand what that means.
Yeah, and for guys that that may not know, just get with your site leads, get with someone that might have done this quite a while, and they'll give you further direction on that. It's pretty easy once you start looking at it. It's a pretty easy concept to pick up. Just get with your guys or just follow up on this afterwards. All right, guys, great discussion. Any other questions, comments? I think we're probably at the top of the hour, a little bit past that. Anybody have any other comments or any other new business? Okay, just as a reminder, again tonight, Nita at night, everybody is welcome. And if there's nothing else, we'll go ahead and pass this on to Ramona.
Thank you, Matt. And I appreciate the conversation, guys. Good discussion. Okay, so we're going to go ahead if there isn't anything else as far as roundtable or just information share. Just anyone have anything else to contribute to our meeting today or just general information? Just want to give everyone a heads up. 401k meetings have already started. If you are participating or want information, reach out to Carmen for your Fidelity 401k benefit. Okay, so I know that the shop here, please send me your attendance. That would be fantastic. Florida CBS Group, if you would do the same. Field Services, if you will please stay with me for just the next 2 minutes. We're going to go through roll call. Okay, Joey Asciutto, I have you. Tony Asciutto, I have you. Nick Botkin. Good morning. Jim Botsford.
Good morning, Ramona.
Good morning, sir. Let me find my cursor. And Jason Carlson, I have you, sir. Adam Carter.
Thank you.
Thank you, sir. Darren Churchill.
Good morning, Ramona.
Good morning, Darren. Sean Conley. Tim Conley. Rob Coombs. Derek Dahlstrom. John Garbarino.
He's here, Ramona.
I'm here. Good
Thank
morning.
you. Thank you. Good morning, John. We have James Green. Toby King. Tim Klosterman, I have you, sir. Dave Marin.
Good morning,
Darren
Ramona.
Miner. Good morning, Dave. I have you. Darren Miner. Chris Parrish. Good morning, Chris. I have you. And did I miss it? Oh, Joel Wilbur, I have you. Oh, I missed quite a few. Never mind. Hang on. Whoop. Okay. Wally Schwantes, I have you, Wallace. Let's see. Matt Thomas.
Good morning.
Good morning. Salman.
Hey, Ramona. Good morning.
Good morning, sir. Matt Wallace, I have you. And Jaden Warren.
Good morning, Ramona.
Good morning. Joel Wilbur, I have you as well. And did I miss anyone? Okay, gentlemen, thank you very much for your time. We went a little bit over the hour. Appreciate your attendance, and you have a good, safe week. Thank you.